In Unit 5, Section 1, we're going to look at the fundamental counting principle. Before we get into what that is, we're going to first talk about independent and dependent events. So basically, if two events are independent, one does not affect the other. If two events are dependent, one event does affect the other. Okay, so you just got to kind of logically think about this. So let's look at number 1 here. Choosing the color and size of a pair of shoes. Okay, well, the size doesn't affect the color doesn't affect the size, so those two events would be independent. Okay, and then let's look at number 2. From 15 entries in an art contest, a camp counselor chooses first, second, and third place winners. So if you look at this, there's 15 entries, and they're going to choose a first, second, and third place winner. Okay, so kind of 3 things going on there. Now, if they choose a first place winner, that affects who can be second place, because that person that was chosen as the first place winner cannot be second place. And likewise, the third place winner cannot be whoever won the first or the second place. So those are dependent. Okay, then let's go down to actually finding probabilities of independent and dependent events. And this really involves the counting principle. So let's go down and let's look at number 7. We're going to solve each problem. An ice cream shop offers a choice of 2 types of cones and 15 flavors of ice cream. How many different 1-scoop ice cream cones can a customer order? So for instance, that's like a waffle cone and a regular cone, and then there's 15 flavors to choose from. So how many total possible choices? And what the fundamental counting principle says is that you multiply the number of choice of each particular thing together. So how many types of cones? And I like to do this with blanks here. In this first blank, I'm going to put the total number of choices of types of cones that I have. Well, I have 2. And then I like to say, okay, I got a second blank here. How many choices for flavors of ice cream do I have? 15. And the fundamental counting principle says you multiply these 2 together. So 2 times 15 would be 30 total choices. Now, we're not really listing out the choices, but you could do a tree diagram to come up with all the different combinations or the types of cones with the flavors. But there would be 30 total. Now let's go down to number 12. Carlos has homework to do in math, chemistry, and English, so 3 different subjects. How many ways can he choose the order in which to do his homework? So if you think about this, what's he going to do first? What's he going to do second? And what's he going to do third? And you just look at individually at each spot the number of choices. So what could he do first? Well, how many choices does he have for that particular spot? Well, he could do math first, chemistry first, or English first. So there are 3 possibilities. How many choices does he have for second? Now, these are really dependent events, because whatever he chooses to do first can't be second or third. But we're still going to use the counting principle, and so once he does something first, how many choices are left for what he does second? Well, only 2. And then once he puts something first and something second, or does those homework in that order, then there is 1 left for the third spot. And the fundamental counting principle says you multiply all the choices together. So 3 times 2 times 1 would be 6.